its 3D of printing. This provides us a fast and easy fabrication process without demanding of processing. Without it, demanding post-processing. It's very focused on this journal. And then Blueprint is a process very special in this class. It's mean in 3D printing, bioprinting is a very special class. Because of that, we focus to study about it. Bioprinting is process of acquiring 3D printing, structural design, use filament, and then technologies until now still in development stage. Application in various engineering continues to increase, such as tissue engineering. As a forming material in 3D printing, many types of commercial filament have been developed. Filament can be produced from either natural or synthetic biomaterials alone or combination of two as hybrid material. Filament manufacturing method is called FMD, is shown in this picture. You can see this is innovated at 1989. So yes, this hybrid we can take from many kinds. There is rice straw. There is very much what we see that plant, sugar cane, bamboos, and etc. And also we can add polymer, adding to put in PCL. Okay, the conclusion from this paper. This paper discusses the current research in development PCL filament for recent trends in 3D bioprinting. 3D bioprinting technology utilizing PCL filament has entered a very promising research development stage. PCL is a strategy in 3D printing to be better control interconnectivity and porosity spatial. Okay, that's all. Thanks for.
Okay, thank you, Ms. Khairul Amni. Okay. Ladies and gentlemen, this is the question and answer session. Please, if you have a question, you can raise hand or chat room feeder. Any questions from ladies and gentlemen in here? Okay, maybe no question. We come up to the next session. I would like to invite Ms. Dina Erlinawati with the title Nitrate in the Groundwater of the West Side Magelang Regency, Central Java. Please, Ms. Dina Erlinawati. Okay, thank you for the screen. Please, the screen is yours.
Okay, thank you for the opportunity and chance so we can share our research about nitrate in groundwater of the west side of Magelang Regency, Central Java, Indonesia. First, I would like to introduce our team. My name is Dina Erlinawati, and my supervisor, Doni Prakasa Eka Putra, and Miss Anastasia Dewi Titisari. We are coming from Department of Geological Engineering, Faculty of Engineer, Gajah Mada University. To the presentation, the first is introduction, and then location of study area, the third method of research, and then research and discussion, and the last but not least is conclusion. First, to the introduction, groundwater is one of the most important source of drinking water in many cities and rural communities, and accounting for approximately 20% of the world's fresh water supply. Based on PUPR 2016, 52% of water consumption in Magelang Regency, Central Java, Indonesia was supplied by groundwater, and this is area inhabited by 1.3 million people who use groundwater to produce sanitary waste every day. This area also has a large food estate that has 200 kilometers body fields, which is the possible of using chemical fertilizers. Due to the concentration of the intensity of fertilization of sanitary waste, which are pretty high, Magelang Regency is susceptible to groundwater pollution by nitrate. On the other hand, nitrate affects human health when it is converted to nitrate in the stomach was quite important. Nitrate has a potential long-term impact on this contamination, therefore it should be necessary point to understand and prevent since remedial action is difficult, while nitrate contamination continues to increase every year. So this study aims to determine the characteristics of nitrate in the groundwater of the west side of Magelang Regency, Central Java. The location study is on the part of slope of Mount Sumbing volcano. That administratively, the boundary area is Temanggung Regency in the northern boundary, Wonosobo Regency as the western boundary, and the eastern boundary is Progo River. And the southern boundary is the Yogyakarta province and Borobudur subdistrict of Magelang Regency. This area is included on two regional geology maps of Semarang Magelang Seat and Yogyakarta Seat. The lithology consists of sedimentary rock of Old Sumbing Mountain, lava and andesite porphyry, Condong volcano rock, Gianti volcanic rock, and Kekep volcanic rock, and then Telomoyo volcanic rock, and the dominant was Yong Sumbing mountain deposit. There are many fractures are found in the northwest southern direction, and many springs seem to be correlated on these structures. Method of research, we are define the method into three parts. The first is observation and sampling, the second was laboratorium test, and the third is result and discussion. On the observation and sampling, we took 70 water samples from springs, deep wells, and dark wells. And then second part of laboratorium test, we are analyzing the major ion in the anion consists of chloride, nitrate, sodium sulfate, and then bicarbonate. And then the cation consists of sodium, potassium, magnesium, and calcium. We are using Metro-Ohm 850 professional IC or ion chromatography. The research and discussion, we ensure that the data of analysis are correct, whether checking the reaction error are less than 5%. And then we can know the nitrate concentration according to WHO. And the third, we are analyzes the origin of nitrate based on ICoGEE 2021. And then the fourth or the last, we find the paper diagram plot for knowing the phases of water. This is the distribution samples groundwater in the study area. We took 11 stations of spring, 5 stations on deep wells, and 1 station of dark wells. Result and discussion. This is the data shown about the anion and cation in water. And the results show that the highest nitrate content is relatively low compared to the maximum limit of nitrate content in drinking water, which is 15 milligram per liter according to WHO 2011. It can be seen clearly that the average nitrate content in groundwater was 3.9 milligram per liter, with deviation standard was 5.12. The smallest value was 0 and the highest value was 20.78 milligram per liter. It also can be recognized that the groundwater sample from deep well and hot spring in the 33 station contain very low concentration of nitrate, which is 0 milligram per liter, meanwhile other samples show relatively higher concentration of nitrate. And then from the origin of nitrate, based on Aqueous 2001, the distribution of nitrate chloride concentration ratio on the west side of Magelang Regency has 1 to 8 defined one, which is indicated that the nitrate may origin from phases. It should be noted that the groundwater samples stationing 32 and 33 were not included in the protecting area chloride because the significant differences in nitrate content. It is estimated the samples which have 0 of nitrate content are originated from deep groundwater system which is not affected by surface pollution, while the other groundwater where detected nitrate content are presumably comes from shallow groundwater system. And then from the phase before, we will know the phases groundwater in this study area using paper diagram plot. And this is show the paper diagram plot of the study area. The interpretation from the diagram based on Morris, the distribution groundwater ion, so that the phases of groundwater are classified into two different sources, which are dominated by calcium bicarbonate and then natrium chloride. The calcium bicarbonate is a common shallow groundwater type with near recharge area, and in the other hand, the sample from stationing 32 and 33 are classified as natrium chloride. So the groundwater definitely comes from deep groundwater system with salinity water. The conclusion from the research, we can know that the nitrate of the study area is not yet polluted by nitrate, and the nitrate concentration is groundwater is shown below. The average was 3.9 milligram per liter, and then the standard deviation was 5.12, and then maximum was 20.78 milligram per liter, and the minimum was 0. The origin of nitrate coming from phases, but still in small quantities. And then the deep groundwater system existing in the study area have not detected nitrate content, but cannot be used for supplying domestic water needs due to the high salinity of the water. I mean in stationing 32 and stationing 33. And then the last is, it is necessary to protect shallow groundwater resource immediately for sustainable use of groundwater resource found in the study area. This is the end of the presentation. If you are having any question, feel free to ask. Thank you for your attention.
Okay, thank you, Ms. Dina Erlinawati, for the presentation. Maybe in the next session, this is the question and answer. Any question from the other presenter? Okay, if no one asks, we're into the next presenter. And I would like to invite Mrs. Nelly Wahyuni with the title Absorption Capacity of Ca2+ by Hydrochloric Acid Activated Choline. Please, Mrs. Nelly Wahyuni, the screen is yours.
Thank you very much.
Okay.
Okay. Thank you very much to the moderator. Good afternoon, all the presenters in this room. Today, I would like present our research about how we use kaolin to absorb calcium, and then we measure the capacity absorptions. I am Nelly Wahyuni from Tanjung Pura University, Pontianak, Indonesia. The research is the idea of this research is come from that in industry, one of the resources that's very important is water. They use for raw material and then for boiler or others. And then one of the problem is sometimes we find that the waters is contains of ions that we don't need it. For example, calcium or magnesium or spirits. And then these cations or ions can deposit in pipe walls and then impact to the operating unit of industrial machines and then caused by these ions. So we try to get low solutions using adsorbent that we use kaolins. And then the concept of the absorption is there is adsorbent, which we use kaolin, and then adsorbate is calcium ions. So the goal of this research is to find a cheaper solutions for handle hot water treatment using local industries by using local natural resources at adsorbent. This is kaolins, and then in point of view of the chemist, the structure is like this, combined with 1N1 structure, octahedral and tetrahedral structures. So in this research, we use kaolin from Chapkala Bengkayang Regency, and then we activate it using hydrochlorides. We have presented this activation method with another seminar. And then from this paper, we find that activated kaolin with 6 molar hydrochloric acid can absorb 68% of magnesium. And in this research, we use this kaolin to absorb calcium. So the methodology is we use some medical, and then the equipment is using standard glasswares, and then furnace for calcinations or treatment. And then for the determinative methods, we analyze the optimum contact time, and then we variate the calcium concentrations, and we calculate the maximum absorption capacity. For determinations of optimum contact times, we prepare kaolin activated with 6 molar hydrochloric acids, and then we stir and mixture with some compound of calcium ions with some variation concentrations, and then for calculating the supernatant, we treat with ethylene diamine. And then for the maximum absorption capacity, we variate the concentrations of calcium, and then stir the mixture for 150 minutes and stir in 150 PMs. And then we analyze the supernatant and calculate the absorption capacity using equation Langmuir and Freundlich equation. So this is the results. The contact time optimum we find here is in 150 minutes with absorption capacity lines is only 33, but we use active line, we can increase up to double 68%. And then the absorption capacity of line and activated lines, we can hear from the pictures. And then using Langmuir model and Freundlich model, we can see here that lines have 0.18 milligram per gram, but acid activated line has a maximum absorption capacity up to 0.346 milligram per gram. So for the conclusions, activation of line using 6 molar hydrochloric acid enhance the absorption capacity of calcium ions. And based on the Langmuir model isothermal absorptions, each gram of activated line can absorb 0.346 milligram of calcium ions. I think it's enough my presentation. Thank you very much. Terima kasih atas perhatiannya.
Thank you, Mrs. Nelly Wahyuni, for the screen. Okay, this is the, ladies and gentlemen, please, if you have a question, you can raise hand or using chat room to Mrs. Nelly Wahyuni. Any question? Any question for other presenter? Okay, if no one asks the question, thank you, Mrs. Nelly Wahyuni. We're into the next presenter. For the next presenter, we would like to invite Andi Muhammad Ilyas with the title Forecasting Model of Power Generated by Wind Power Plants. Please, Mr. Andi Muhammad Ilyas, the time is yours. Andi Muhammad Ilyas. Oh, okay. If Mr. Andi Muhammad Ilyas is not come, we would like to the next presenter. Miss Lena Luciana with the title Biogas Production Modeling System from Coal Manure Waste to Strengthen Energy Security in Facing the COVID-19 Pandemic. Please, Miss Lena Luciana, the screen is yours.
Thank you, moderator. Okay, good evening, everybody.
Okay, thank you.
Okay, can you see full screen? Yeah. Okay, good evening, everybody. I'm very pleased to see you all. Thank you for coming to this presentation. Okay, allow me introduce myself to you. My name is Lena Luciana from Indonesia Defense University with the major energy security. Today, I'd like to discuss about biogas efficiency from Kaudang waste in strengthening energy security during the COVID-19 pandemic through a dynamic modeling system. By authors, they are Lena Luciana, Nugroho Adi Sasongko, Yanif Dwi Kuncoro, Muhammad Fahrudin, Adil Fajar Widrian, Ahmad Munawir Siregar, and last Ahmad Fidura. Okay. We know that during the COVID-19 pandemic, all energy needs per type and sector decreased, except for LPG type energy and the household sector as a result of the PSBB policy. The increase in LPG types was 0.6 until 2.4 million BOE, while in the household sector, it was 2.36 until 6.9 million BOE. And the gap between these two variables caused the growth of the LPG import ratio to increase by an average of 4.8% per year. And therefore, it is necessary to make effort to suppress LPG import by increasing the supply of NRE in the household sector with biogas production. And in 2020, the supply of NRE decreased by 9.9 until 15.3%. It also refers to the result according to the Purnama Yuskiantoro Center or PUAC research. There are 10 main problems in the energy sector, including the non-optimal use of NRE and dependence of on import of fuel and LPG. So the government has pursued a biogas development program to suppress the growth of LPG import by increasing the NRE. Mixed work the Biru. Biru is biogas rumah program. So what's the matter of biogas development? First, the barrier to biogas production is related to the high cost of building biogas infrastructure. And in addition, the community has not been able to predict the amount of savings made by biogas production. It refers to not efficient. So in this paper, we talk about biogas efficiency from Kaudang waste in strengthening energy security during the COVID-19 pandemic through a dynamic modeling system. So the research aimed to look at the biogas efficient and saving energy and cost modeling system from the resulting Kaudang waste. With the method that studies the literature is based on modeling data and based on data obtained using PowerSim 10. Okay, let me tell this process, energy demand conversion. First, we have to convert the average energy demand for LPG in the household sector on a regional scale is 2.4 million BOE. Convert to methane from BOE unit to meter cubic unit. Based on the metric conversion, state that in 1 meter cubic,